Hello everyone, in this video we will learn about linear regression. So what is this linear regression? It is a statistical method which is used for predictive analysis. So basically it is used for the prediction problems in machine learning. So here the linear regression actually it shows a linear relationship between the independent variable and the dependent variable. So you can see here in x-axis we have independent variable and over y-axis we have dependent variable. So the relationship between this independent variable and the dependent variable is linear. That is why it is called as linear regression. So if there is only one input variable, then it is called as simple linear regression. And if there are more than one input variable, then it is called as multiple linear regression. So this linear regression, basically it is a supervised machine learning algorithm. As I mentioned in my previous video that for supervised machine learning algorithm, we have regression and we have classification. So this linear regression is a supervised machine learning algorithm. So what it does is it tries to apply relation that will predict the outcome of an event based on the independent variable data point. So here we can see these are the data points. Here this green color one data points. Here this one is x-axis and this is y-axis. So this is y, this is x. So x is the independent variable, y is the dependent variable. So based on this the data points, you can see here x and y there is a linear relationship between the independent variable and the dependent variable. So we'll be trying to fit the best fit line for this data points so that it is fitting the straight line equation. So here you can see since it is as I already said, the relationship between independent variable and dependent variable is linear, we can represent it as a straight line equation. So basically straight line equation is given by y is equal to mx plus c. So as you know that in this m is slope and c is intercept. So what is this intercept? See, slope means the angle by which the straight line is passing through. Now the intercept means the point at which this line is straight line is cutting the y-axis. So this is the value which we call that intercept, see, y-intercept. So basically we can write, I am representing it as y is equal to ax plus b, where you can relate this equation with this equation. So a is nothing but it is equivalent to m. M is slope and c is intercept. So a is slope and b is intercept. In some textbooks or some references, it will be written as y is equal to bx plus a. Or in some book, it may be written as y is equal to a1x plus a0. So please note that you don't have to see, you don't have to by heart this equation, the values variable a is equal to so and so equation, b is equal to so and so equation. Please remember that whichever reference equation you are taking, whichever variable is associated with that x, that is the slope, and the constant one is the intercept. So it can be, this can be b or this can be a, but depending upon whichever equation you are referring, b can be the equation equivalent to a in a for this equation. So when I am finding the value of a for this particular equation, that a and this a won't be same. This a will be the b value here in this first equation because that is the intercept. So remember it as the value is slope and intercept instead of remembering it as variable names a, b, a0, a1 like that. So a is the slope of the line and I'll be using the equation y is equal to ax plus b throughout this video. So a is the slope and b is the intercept. Remember that a is the slope, and if this is the equation you are referring to, then b becomes slope. So that expression for a won't be will be wrong here in that, but if you are using the same expression for a of this equation in this second equation, then that will be wrong. So remember that a can be remember a as slope and b as intercept in this particular case. So let us consider an example here. We have the data set x is 0, 1, 2, 3, 4, y is 2, 3, 5, 4, 6. Okay. So what we are going to do is here it is being asked to estimate the value of y when x is equal to 10. So here you can see the last value of x is 4 and you are asked to find the value of y when x is equal to 10. So this value you are supposed to find. How will you do this? So for this we will be using this regression equation. So what is that one? As I already said, we can use this equation y is equal to ax plus b, and the expression for a and b I am giving it here. It has already been solved. I am not going into the derivation part of this. So a is this one and b is, a is here, b is here. And one more thing you remember is that this equation, that is xy bar minus x bar y bar, the first equation which is written in red, that again is equal to, I have written one black color equation here. See, in some of the references you can see this equation is being used, and some of the references this equation is used. But please understand that both the equations are the same. So when you simplify one equation, you will be getting the other equation. So for solving the problem, I am going to use this equation. You can use either one equation because both give the same answer, because both equations are the same when you simplify. So A, I'll be using this red color, the equation which is written in red color, and B, I'll be using this equation. So first thing what you have to do is, from this data set you have to form the table, and when you're forming the table you have to see which all values you need. From this equation you can see xy is required, xy bar is required, x bar is required, y bar. What does this bar represent? That represents the average value. So then x square is required. So you will be forming a table in which here x you know, y you know, because it is directly, that is a given data. Now from x you are finding x square, then from x and y you are finding the product of x and y. So what is this x square? For the first value 0 square, that is 0. Then here 1 square 1, then 2 square, here you are getting it as 4, then 3 square you got it as 9. Similarly you are completing the table. And what is this xy table? You are taking the product of x and y. So 0 into 2 0, then the second value 1 into 3 3, the third one 2 into 5 10. So similarly you are completing the table. Then once you complete these values, then what you have to do is you create a row with sum. So what you can do is, here for the first column you take the sum of all the values. What is that sum? 0 plus 1 plus 2 plus 3 plus 4. So you got the value as 10 here, sum. Similarly, sum of this y, you got it as 20. Then sum of x square, that is 0 plus 1 plus 4 plus etc. You got it as 30 here. What is the last column? xy. Take the sum of this xy. You got it as 49. So you got the sum of all these values here. So the next step what we have to do is, we will be finding the average value. How will you find the average value? That is nothing but sum divided by total number of data points. Okay, so for x you have how many data points? 5 values are there. So sum is 10 divided by 5, you will be getting it as 2. What about this y? 20 divided by 5, you got it as 4. What about x square? 30 divided by 5, you got it as 6. Then xy, 49 divided by 5, you got it as 9.8. So you got the average value. Now what we'll be doing? We will use these values, you will substitute these values in the equation for A and B. So now you got all these values from the table, and you know this is the equation for finding A. So xy bar, so that we already know it is 9.8. What is this x bar? X bar we already have, it is 2. And what is y bar? It is 4. So 2 into 4 divided by, what is the x square bar? X square bar is 6. So you can write it that 6 here. Then what is this x bar square? X bar we already have 2 value. Then what you have to do? You have to square that one. So you got it as 4 here. So we substituted all these values and you got the answer as 0.9. Similarly, for finding B, what you have to do? The equation is y bar minus ax bar. So y bar is already known, that is 4, minus a we have found it here, that is 0.9, that you have to substitute it here. Into what is x bar? X bar is 2. So that x bar we substituted it here and we got the value of 2.2 for B value. Now we got the value of, see what is the equation? Y is equal to ax plus B. Now we found the value for x, we found the value for, we found the value of A and we found the value of B. Now the question is, find the value of y when x is equal to 10. So x is given 10 and you are going to predict the value of y. So how will you predict the value of y? You substitute x is equal to 10 there. So we are substituting in this equation, that is 0.9x plus b is 2.2. So we substituted it x as 10 here. So you got the value as 11.2. So what is the value of y when x is equal to 10? So the value is 11.2. So we have predicted the value of y for a particular value of x using the linear regression formula. We will solve one more example. So here the sales of a company for each year is shown in the table. So here this X is the year and Y is sales in $1,000,000. So what we are supposed to do is we are supposed to estimate the sales of the company in 2012. So here you can see up to 2009 only the data is given, and we are supposed to predict the value for 2012. This value we have to predict it. So how will you do? We again use the regression formula. So what is the first step? First step is you have to form the table from the given data set. The first two columns will be, one will be X and the second one will be Y. So X is there, Y is there, then the third column is X square and the fourth column is XY. So in the similar manner, we are finding X, Y, X square, then you found the sum of all these values. This is then once you find the sum, what you'll be doing, how many points are there? 1, 2, 3, 4, 5. 5 values are there. So for finding the average, you have to divide this each value by 5. So 10035 divided by 5, you got this value 2007. So 142 divided by 5, you got it as 28.4. Similarly, this value divided by 5, you got it as this one. This value divided by 5, you got it as this one. You can see that the values here is very large, so it is a little bit complicated to handle, but later in this video I'll explain how you can avoid this bigger numbers. So this values you got it. Now what is the next step? You have to use the formula and substitute it. So this values we already found. So A is this one. So you can substitute this values here and find X, Y bar. You already know the value. X bar you know, Y bar you know. Then X square bar you know. Then you have X bar square. X bar square is nothing but you take the value of this one and square it. So this one you are getting. So this value A, you got it as 8.4. Similarly, you are using the formula for B, that is Y bar minus AX bar. So you are using Y bar is here 28.4. A is found here, that is 8.4, that you are substituting it here, and X bar is what? X bar is 2007, that we have substituted it here and we got the value for B also. Now what is that one equation? Equation is Y is equal to AX plus B. You are substituting the value of A and you are substituting the value of B here. Then what is the unknown quantity? X. And what is the value sales of the company in 2012? So what is given? You are going to find what is X. X is the year. So X is 2012 is given. So you are going to predict Y. So substitute the X value of 2012 in this equation, that is here. And then when you substitute it, you will be getting the answer as $70.4 million. So you have predicted the value of the sales in the year 2012 by using regression method. So this is how you can use regression, linear regression for predicting future values. But I said that, you know, when you are dealing with this bigger values, to make the calculation simpler, what you can do is you can normalize that year. What we'll be doing is, you know, simplification, what I do is instead of X is what? X is the year. So instead of X, I am converting it into T, where T I have chosen it as X minus 2005 because your initial value of X was 2005. Okay, so basically what we are trying to do is we are trying to make this as 0. So we are normalizing it. So X minus 2.2005, the X minus 2005, the first value becomes 0. So similarly, the second value becomes 1, 2, like that. Okay. So we got this one. You can see that we have converted the years into 0, 1, 2, 3, 4. Then sales, it remains the same. We have changed only the value of X. So this is X minus 2005, given all these values to you. Now instead of X, we will be using the variable T. Please note that we are changing the variable X to T. So here we are using T, then Y, then T square, Ty. So instead of X, we have changed to T. Then similarly, you are finding the sum, then you are finding the average. So I'm not going into the detail. Now you understood how to find the sum and find the average. So you found the values for all this average. Then these values are known now. Then what you have to do? You have to substitute in the equation. So in the equation, original equation, what instead of X, we have replaced it with T. You can see here, instead of X, we have replaced everything with T. So then you are substituting all these values which we have found, and we got this A as 8.4. And the second one in this B, we have used this values, and we are substituted this a also because a is required. A is 8.4 and you got the value as 11.6 here. Now, what is the equation? Equation is y is equal to, instead of ax plus b, we have at plus b now. So now a is known to you, b is known to you. And what is that? T is given. So t actually, x is given. So we have taken t is equal to x minus 2005. And what is that one? We are supposed to predict the sales in the year 2012. So what we will be doing? So x is 2012, x is given. So 2012 minus 2005. So here x is given as 2012. So we are substituting the value of x here. So you got this one as 7. So what we'll be doing, instead of this here, this t, we will be substituting this 7. So what we have done, 8 point, y is equal to a is 8.4. So this is the equation, 8.4 plus 8.4 t, t is 7 plus b, b is what? B is 11.6. You got it as $70.4 million. So this is the predicted value. We can see the previous value, the previous method also you got the same value here. And please note that if you are getting a negative value, don't remove that sign, keep the sign, because here you got a negative value. So here instead of y is equal to ax plus b, you can see here there is a negative sign because of the b is negative value. So don't ignore the sign, you have to use the sign. So you can see by using both the methods you got the same values. And please remember that when you are using this formula, please remember which value of what is the value of a and what is that equation for b. And a is for slope and b is for intercept in all the problems which I have taken. But if you are referring to somewhere else wherein which you have bx plus a, then the equation for a which I have used, it becomes the equation for b in that particular problem. So please make note of this one. I hope you understood how to use this linear regression method for prediction of future values. Thanks for watching. Thank you all.